This is problem 46 of chapter 12 of Giancoli 6th edition. So we have two loudspeakers and they are 2.5 meters apart. That information is not important. What is important is the distance between the speakers and the person. Okay, so we have one speaker here and this speaker is 3.3 meters from a person. All right, so let's put here 3.3 meters. There is a second speaker here and the distance is 4.5 meters. Okay, and they give us the temperature so we know what is the speed of sound. And comes the questions. First one, what is the lowest frequency at which destructive interference will occur at this point, right where the person is? Well, we know that we get destructive interference when this distance here that I'll call D2 minus this distance here that I'm calling D1 is equal to half of a wavelength. Okay, so I know that I get destructive interference when this is true. So from here, I'm able to find this wavelength. With this wavelength, I'm going to write this equation, speed of sound, wavelength multiplied by frequency, and we'll be able to get this frequency. Okay, so we are done with question A. Question B, calculate two other frequencies that also result in destructive interference at that point. When can we also have destructive interference? Well, here what we wrote, this half, is the first case, is the lowest frequency that will give us destructive interference. But we can also get destructive interference if D2 minus D1 is 3 halves of the wavelength. Okay, and we can also get if D2 minus D1 is 5 halves of the wavelength, and so on. So the next two frequencies will come from here. So first you get the wavelength, and then you use this equation to get the frequency, and then the second one will come from here. You get the wavelength, and then you get the frequency.